Alright, welcome back to part 2 of implementing variables inside our calculator. So in our previous video we had an error here on line 545. That's because I accidentally had a double parentheses and I forgot to add, but if we actually have a variable, we need to return none. And the reason why is because here we do not want to print anything out. So we're going to return none, that way value is none, and we just have an assign statement. So here we can say x is equal to 5, which is interesting. Say x. So we're having some problems here. So after debugging for a little bit, I found out here that once we had the variable, we check to see if we reach the end of the list, end of the input, and then we return the value. We do not want this to happen. So we're going to say if the token is not this, then we're going to return none. Or what we could do is have the equal sign and simply pass this up here. This way, if it does equal the end and we're at the end of the input, we make the variable, we update it, we return none. If we don't make the end of the input, we just return none. So this should work. I'm going to say x is equal to 5, x. So here we have a memory error. So I found out that we had a memory error simply because we forgot to make a stopping condition in our infinite loop here. So once we reach the end of the input in our example input of x into standard in, we reached the end of the input and we simply appended it, but never done anything else. So we actually need to have a return statement. So we're going to return tokens. So now let's play this again. X is equal to 5. X is 5. Let's say y is equal to 34. X times y, which is 5 times 34. So here we have a working calculator that supports variables. So we can say now, let's say variable is equal to x times y. Variable is equal to 170. X raised to the y power is an extremely large number. Let's say x raised to the y, say x raised to the y divided by variable. So now it's this number divided by 170. So as you can see here, we've implemented a working calculator that supports variables, addition, subtraction, multiplication, division, and exponentiation and negation. And this is an extremely powerful tool, and it wasn't extremely hard to implement except for following through a few logical errors and knowing how to manipulate our grammars and our scanners to appropriately organize our data. This is probably going to be the last video in this series on recursive parsing for calculators. Hopefully you've learned how to implement this kind of material, and this can be used for any kind of grammars. So this was used for a calculator, but you can also use this for parsing any kind of input that can be organized into a grammar, like a CSV file, or just a program in general, like a compiler. You can make your own compiler to organize data and organized code, or organize any kind of input from a file that can be patternized. So hopefully you guys have learned something from this. So please subscribe, and until next time.